once I have my triangle labeled like this, I can use the information from the cosine to figure out what the lengths of all the sides are. Okay? Cosine tells me what? Cosine of theta is equal to what? It's the adjacent side over the hypotenuse. Right? And so once I give you that information, you can take this and you can fill in this picture. And you can identify where it's going to go. The adjacent side is going to be down here, so this is going to be, I'm going to put the -3 there. Okay? And then the 7 on our hypotenuse right there. And now, I need to use my Pythagorean theorem to find that opposite side. Okay? My opposite side. When I do that, what do I get?
Yeah, 2 squared.
Okay. So opposite squared is equal to 7 squared. In this case, minus 3 squared. Calculation that in the base square of 40. Or theoretically. Either way, doesn't matter. If you leave it at a dot for 40, I have no problem with that. Alright, so there's the length of the opposite side. I have enough information now to figure out what the tangent is, right? What's my tangent?
2 squared. Or, sorry. If you're on the other side.
Okay. Tangent, if we recall back to tangent, tangent is opposite over adjacent. Okay. And so in calculating that, the opposite side is, again, 2 squared is 10. So I take 2 squared is 10, and I divide that by my -3. Alright, and then what about sine? Sine is opposite over hypotenuse, which when we take our values and plug them in, that's 2 radical 10 over 7. And there's our answer. Now, you may ask the question, well, how did I know to put the -3 down here on this adjacent side? How do I know that the negative didn't go with the 7 over here? That's where these restrictions of 0 less than x less than pi come into play. Okay? What you have to remember is that in our unit circle approach to trigonometry, values of cosine in the first quadrant are all positive, right? Because the value of cosine measures the x value on the unit circle. So I know that my angle can't be over here because cosine is positive over here. So that means my my angle has to be over here somewhere. Well, again, since I'm measuring the horizontal distance with my cosine, that's what I chose to put the -3. That's why I chose to put the negative sign on the 3, is because this distance, in terms of using the cosine, is negative. And that's where the -3 over there comes from. Okay? So that's why I need to put it there. Okay? Not too bad, right? It's easy when I do it. Okay. Yeah, then.
So we're not going to email us radian numbers for the squares?
Oh, yeah. You need to know all of the trig stuff. You need to know the basic facts of trig, including the conversions from degrees to radians. That's stuff you should know. And radians to degrees. You obviously need to know these facts about how to evaluate the cosine. You need to know that it's opposite over, or adjacent over hypotenuse. And you also need to know that it's the x value on the unit circle. Same thing about the sine is the y value. So you need to know those facts. You need to know the basic angles, the values of basic angles like cosine of 45, sine of 45, sine of 30, cosine of 30, tangent of 30. You need to know those. Alright. Is that it? You done?
You have an equation of natural logs of y values and natural logs of x values and the parentheses y equals.
Okay. Can you give me the exact equation?
Yeah, natural log of y minus
Okay.
natural log of 0 equals x plus natural log of x.
X plus the natural log of x?
Yep.
Alright. And the goal here is to solve for y in terms of x. we go. How do we do this? What's that?
Base E everything.
We can't do that right away. Because if we base E everything, how do I redo this? If I went that route, this is what I would get.
Oh, that's what.
Okay. Right. When I do this, ultimately my goal is that the E and the natural logs will cancel each other out and everything drops down and we're fine.
Yeah.
However, the E and the natural log will only cancel out if the E and the natural log are the only things that exist there. There can't be any subtraction going on, no addition, no division. It has to be just E to the ln of something to get the something to fall down. Okay? This is my goal. My goal is to get it to look like this. What I have right now is this. Okay. Same thing on the other side. So, I need to fix this. Make it better. How can I do that? Okay. So what we'll do, instead of that approach, is we'll use our properties of logarithms to say, if you're subtracting logarithms, you can rewrite that as a single logarithm. And the only thing you have to do is divide the two things inside the parentheses together. Okay? So we can simplify the left-hand side like this. What about the right-hand side? Just go like this. Okay. What do I do with the right-hand side? Notice on the right-hand side we have an x sitting by itself, and then an ln of x as well.
Did you put the X on, like, top of the other X, like, the exponent?
I can't do that because I'm not multiplying the x by the natural.
Oh.
If there was multiplication here, then that would be fine. But with the addition, I can't do that now.
You subtract the natural with X. Did you divide the X's out?
I can't divide the x. I can't get my x to come outside this parenthesis on its own. There's nothing I can do to get that x to come out of the parenthesis. Jake, you said to subtract the x to the other side? The natural log of x to the other side? Okay, if we were to do that, and again, there's nothing wrong with that, let me come down here and draw another line. So what I have is a natural log of y minus 1 minus natural log of 2 minus natural log of x. All that equals x. Okay. If we go this route, and there's nothing wrong with this, this hopefully will work out for us. I have 3 logarithms here now. 2 of them are subtraction. How do I rewrite? If I want to do the same thing here that I did up here to get this line, how do I rewrite this left-hand side as a single logarithm? How do I write this side over here as a single logarithm? What does it look like? So when I do all of this, what I should get to the left-hand side now is this.
Should we do divided by?
No, it should not. And here's why. This side right here, if you look at it, the 2 minus signs here can actually be pulled together, making that one plus.
Oh, good.
So when we have multiple subtractions of logarithms, group those together and factor the minus sign out so you can see how those things are going to play together. Okay? In this case, they have to go together first, and then they go down in the denominator, like going to the dance together.
Are you saying that's wrong, though? How we're doing it right here?
Who what now?
Are you saying that's wrong, how we're doing it right
No,
now?
no, no, there's nothing wrong with this. There's nothing wrong with this step. This is just an alternative way of doing it that gets us through a different way. Okay?
That's what I'm-
Both directions will lead to the same answer. It's just this way requires us to make a clever substitution. It's not magic or anything. It just requires a clever identification.
Would we times the X?
We can't times it.
No, the X by itself.
This x
Yeah.
times it by what?
Go to the other side.
We can't. We can't do that.
We don't need
We won't need to. It's okay.
Take it.
We're going to leave it by itself for now because when I have it in this form, I can now use my exponent power stuff to get rid of the natural log. Okay? When I do that, what happens? Well, let's see. I take E here, I take an E here, The left-hand side can simplify to what? Y minus 1 over 2x. The left-hand side is, or the right-hand side is e to the x. Okay? All right, I'm doing fine. There's nothing wrong with this. This is going exactly the way I wanted it to. Okay? All right, my goal here, solve for y. That's all my goal is. All I'm doing is solving for y here. How do I solve for y after this? Multiply the 2x on both sides. So I get y minus 1 equals 2x times e to the x. And then add the 1 to both sides. And there you go. There's y in terms of x. That's it. Yep.
Where'd you get that color substitution?
Up here, if you want to make a substitution up here to get rid of this x by itself, what you're essentially doing is you rewrite x as the natural log of e to the x. When I do that, now I can combine the two logarithms on the right-hand side, and that's the clever substitution that you can make there. Okay? Everything else at this point follows through exactly the same way we had. Okay? Same answer will come about in either.
I've got a question.
Go ahead.
I don't know if you
I've got an answer.
Since we're solving for y right here,
Uh-huh.
could we not move at the very beginning the ln2 to the other side?
You could. You could move the ln2 to the other side, and you could go through all the same kind of work.
Yeah.
Moving the ln to the other side, again, is going to require us to make this move at some point.
Yeah.
But then we just combine everything together the exact same way,
Okay.
and that just gets us down to this answer a little quicker. This is what we would have gotten had we gone that route, had we moved the natural log of 2 to the other side.
Yeah.
When we combined everything, we would have gotten a natural log of y minus 1, natural log of 2x e to the x.
Because, I mean, if I just see solve for y, I'm gonna move everything away from y.
Right, and there's nothing wrong with that, and that's fine. Ultimately, that's our goal in the end anyways.
Yeah.
It's just a matter of how can I get this into a simple form that I can get rid of the natural logs with early. And whichever method you use to do that, as long as it's valid, you get to the same answer. Okay? All right. Other questions?
I'm still looking. Give me a minute.
Oh,
Yeah,
go ahead, Ben.
quiz, there was one where they had like x minus something, there's like constant over x plus something.
Okay. And then what did you find the inverse? Find the main range and stuff like that? Okay. Yeah. So we'll start with the function f of x equals, and let's make it something interesting, 2x plus 1 over x minus 5. Okay. All right. Now, in dealing with problems like this, ultimately, the inevitable happens is they find f inverse of x. Okay. And when they ask you questions like this, there's a couple of things that you should ask yourself before you get started. The first thing you should say is, self, do I really believe that this function has an inverse? So you need to be able to identify whether or not you need to go through the work of finding out an inverse. Now, I'm not evil. The computer system is mostly not evil. They wouldn't ask you to do this if you couldn't. So there is an inverse to this function. But you should be able to understand why. Okay? This graph, if you look at the graph of this function, it has some funky behavior, but all in all, it looks roughly right. Roughly this graph looks like. Make sure I get it correctly here. Roughly, this is what the graph of this function looks like. Okay? Looking at it like this, it's hopefully a little bit easier to see that yes, it does